I would like to welcome you in this new chapter where we're going to zoom in on HDL containers. We have already seen that HDL containers are built-in collection types that we have in the C++ standard library, and they allow us to easily manage data. For example, they take care of memory allocations and they offer a bunch of methods we can use to manage our data. They work pretty well. We have seen a few examples of these. We have seen std vector and std array, but in this chapter, we will explore more on these containers and see the differences between them. For example, which kind of iterators they support, how memory is laid out, and all kinds of crazy things you really need to know about them. So each container is going to store data in its own way. For example, std vector is going to store data contiguously, just like we did for our box container class. And there is another class called dict, which is really not going to be as memory locale as std vector. There also is an std lest container, for example, which is going to scatter elements around in memory, and it is going to set up pointers that point from one element to another. We're going to see how this works in a minute. So the SDL offers different containers for different purposes, so you will have to do your research to know which kind of container is good for your use case. Some containers are good for some things and really bad for some other things, so you will have a chance to explore this. And it is a good skill to know which kind of container you're going to use for your purpose. For example, if memory locality is a good you care about, std vector might be a good class. But if memory locality isn't really that important for you, std vector is going to be costly for your application in terms of memory and CPU time. So you really need to be careful about which container you choose for what you are building with C++. But std vector is a good default because it is like a Swiss Army knife in containers. It is going to give you a bunch of facilities you can use, and its memory and CPU time consumption are really acceptable for a host of use cases. So it is a good default or a good starting point. And then you can study the performance you get with std vector and decide if you want to choose another container that is not std vector. At least this is my workflow when I am working with these HDL containers. So we have a bunch of containers in C++, and they are classified in a few sections. We have sequence containers, which are going to store elements in a sequence. So you will have a bunch of elements organized in a way like this. In a sequence, I think there is not more one can say about this. And in sequence containers, we have deck, we have forward list. We're going to look at these, so don't worry. We have list, we have std vector, which we have talked about a little more. We have std array. We also have associative containers, which are going to be mapping pieces of data together. We're going to see how this works when we learn about these in a minute. We have std set, std map, std multiset, and std multimap. So we're going to also have a chance to learn about these. On top of these, we have container adapters, which are really not containers, but a kind of layer you put on top of containers to make them behave in a certain way. So for example, we might have a stack, a queue, and a priority queue, and we're going to see that these are going to be working with some of the sequence containers we have learned about under the hood, but they will provide a common interface we would expect for a stack, a queue, and a priority queue. I realize some of these things might be in the blue right now, but bear with me. We're going to have a chance to play with this and really do a lot of examples so that you have a pretty strong idea of these HDL containers. Here I am at CPP reference, and we're going to see what the official documentation from CPP reference has to say about containers. So containers are grouped into what we call containers library. And here is a simple explanation they try and come up with. You can read this if you want. But if you go down, you're going to find that we have the same containers we have talked about in the slides. We have sequence containers. We have associative containers. We also have unordered associative containers. We're going to have a chance to see a few examples about this. And we have container adapters, which provide a different interface for sequential containers. So they really modify the interface we get from some sequential containers, and they provide a unified way to work with that interface. We have stack queue and priority queue as we have seen before. And we also have another span container which was introduced in C++20. You can check this out if you want. If you go down, you're going to see the behavior with iterators with some containers. So you can read this up if you want, but I would advise you to come to this when you have done the examples in this chapter here. And if we go down, we're going to find more information on thread safety. This is really advanced. We're not going to go into this in this course. And if you go down, you're going to find different member functions you can get from different containers. So you can see some iterators you have in different containers. You can see the methods you have for element access, capacity, the modifier functions, and all kinds of crazy things you can do with these containers. I strongly recommend coming back to this piece of documentation even when you are done with this chapter, because it's going to give you a bird's eye view on what kind of facilities you have with your HDL containers. This is really all I had to share in this lecture, giving you a soft introduction on these HDL containers. We are going to head over to the next lecture and learn about the Dake class and see some things you can do with it. Go ahead and finish up here and meet me there.